Okay, so hi everybody. Our talk is about cloud infrastructure with Nomad and Podman, two tools that not everybody will know about. And we will see how it can maybe improve your infrastructure as well, not only ours. So, great.
That didn't work.
Just a second.
Yeah. I'm Sebastian. As David said, I only recently joined pascom, and I'm doing the DevOps stuff now here, and I'm in charge of all that site reliability engineer. And yeah, and Tom?
Yeah, I'm Thomas. I'm here a little bit longer. I don't know exactly, maybe some 12 years, and I'm tech lead here, so I'm responsible for all the development work. Both of us, we're working for pascom. For those who don't know about us, we're in the telco business since some 15 years, so we're not actually newcomers. We have a single product based on Asterisk, Camelio, and Janus, and we're building our own client products for all the 5 major platforms. And one of our main focus is really security and usability, yes, for our products. So about this talk, it's a bit different to the other talks maybe here, so please don't expect any detailed zip VoIP web or WebRTC content. It's really high level about containers and DevOps, so we'll see if it still is interesting to you.
Okay, yeah, why did we really need to build a new platform? Well, as Thomas said, we are already in the business for 15 years, and we started first with an on-premise only solution where we delivered those nice little boxes, not the left ones, but the right ones, to our customers. They could buy them, or they could even just download an image from our website, and then they'd buy only a license from us. And then they would install it into their network on either this metal box or on a virtual machine, something like that. And then depending on the license, they could use it from just a little like lawyer's office with 5 users or up to a call center. That would everything would work for all sizes. And if your box would be out of power for the amount of users that you have, then you would just place a bigger server there, and everything would be fine again. And as you know, we're located in Germany, and German customers are known to be quite hesitant to move things into the cloud. But eventually, there was the day that customers wanted us to have the system not in their data center anymore, but in the cloud. And so we decided to build a cloud ourselves. And yeah, what we actually did was we used our on-premise solution and put a lot of those containers that we back then already used in the on-premise solution, and put a lot of them just into one machine, or a lot of containers into a lot of machines. And then we put some Camelio RTP engine Janus in front, and we called that cloud. And yeah, it worked actually pretty well. And if we only had to scale up, we didn't have to scale down. So there was a manual process which needed somebody setting up a new host, including that into the cloud, and then we could set up more containers in our cloud. But the main downside of our setup was that we had a JVM in each PBX system for of each customer. And since we have a lot of customers that only have like 3 or 5 users, that didn't scale well. You know, as soon as you work with Java, you need a lot of memory, and a lot of memory costs a lot of money, and so that didn't work out. But and another thing why we thought it is time for a new platform was that, as I said, there were a lot of manual processes where we had to do things by hand, and there was no orchestrator. And in case of an outage of one machine, all those PBXs were down and had to be moved manually, and there was no automatic solution. Well, but it actually worked, and so we had a lot of time to do research and development, and now Thomas will tell you about some products that we found that could suit our dependencies.
Yes, so we're still in the transition of moving into our next generation cloud platform. So the old platform is still online, and it serves 99% of our customers. But right now we're rolling out the new generation, and we included a bunch of new open source projects into it to simplify our lives and to improve the overall architecture. And one of the tools is Podman. Maybe some of you already heard about it. Podman is a container tool. It's very similar to Docker. It actually has the same command line syntax like Docker, so you can basically alias Docker to Podman and just continue to use it. But from architectural perspective, it's very different. It doesn't have a background daemon. It's a client-only tool. So you start a container, and the container keeps running even if you basically stop Podman again. So there is not the single point of failure that all the containers will stop if I just shut down one background process. Also, the API is very similar to Docker. So for the developers, it's really, really simple to get into it, but it brings a few benefits to us. One is this no background daemon needed. Another one is it's more secure because it can run so-called rootless containers. That's very different to Docker. I won't go into detail here, but you should read up in the internet what it actually means. And also the networking is a bit more flexible than with the Docker. It's more or less the same tool suite that you would get with Kubernetes. So it's definitely worth to look at it. So you might ask, it's similar to Docker, so why didn't you use Docker? You could just use Docker, everybody uses it, right? But for us, it has a few downsides, because if you think back to these boxes that you see in the other slide, one tenant in our world is still more or less like a tiny virtual machine. So we're running systemd in each of the containers, and that's something that Docker does not do very well. So it's not supported by Docker. And actually, that's how Podman started. It was a clash between the Docker team and the Red Hat team, because Red Hat wanted to contribute this systemd integration, and Docker refused to integrate it, and then they started their own tool, and that's what we have with Podman now. Okay, systemd is very important to us in the tenant container because we're using socket activation a lot. It allows us to start basically everything except asterisk on demand. So whenever a customer uses the web UI, we can dynamically start it, or fax server, or whatever the customer needs. So we're only running what we really need in the container, and we're doing this by simply leveraging systemd. So that's what we did for a single container, but we're running a lot of containers in our cloud. And as Sebastian told you, we wanted an orchestrator, and we didn't want to write the code on our own. So also here we were in search for a suitable tool, and we use a tool called Nomad. Nomad is from HashiCorp. Maybe you know another product from them. It's called Consul. And a few years ago in the Camelio world, we already had a talk about that. And so for us, it was a more or less natural choice to use a tool from the same company because it fits together very well. So Nomad is a very lightweight job scheduler. Basically, you can think about it like systemd, but distributed over a lot of machines. Each of the machines needs to run a small agent, and it can run, scale, upgrade, migrate your tasks. It is not limited to, let's say, background services. It can also do a batch processing or scheduled jobs, just like cron would do. Again, one might maybe ask, why did you not just use Kubernetes? Everybody uses Kubernetes right now. It's the hot thing. You need to use it, but we didn't want to, because at the end of the day, we want to scale, but not limitless. We're not Netflix, right? And as you know from the VoIP business, we have a very different traffic routing. We are not really HTTP based. Of course, we have an HTTP web UI and things like that, but it's not, I think, not so simple to get VoIP streams automatically routed by Kubernetes and so on. And also the complexity of Kubernetes scared us at the end. So for us, it just seemed to be the wrong tool, and that's why we choose something else. The benefits that we got from Nomad is most and foremost, actually, it's relatively simple and the footprint is really small. You can get into it just by downloading a single binary, starting it, and running it on your development machine with in-memory storage. So trying it out really takes you something like 30 minutes. Also, an interesting feature is that it can not only run containers, it can also execute things directly on your host, or it can run directly Java binaries. And you also can write your own executors. And actually, the Podman executor was contributed by us because there wasn't a suitable software at the time when we started. And so, yeah, that was the integration that we did between the two products. Another benefit of Nomad is it doesn't really have a single point of failure. In Kubernetes, you have something like the control plane or the control node, and you somehow need to manage the high availability of this thing on your own. In Nomad, you don't have something like that. You have a group of servers, three or five, something like that. And it will be self-contained and high available by default. It brings you also yeah, somewhat limited but still nice UI. You can connect to any node to get it. Of course, you can have credentials and policies like that. And it even gets you a terminal into each of your containers if you want that. So that's for debugging and support purposes, a very nice tool.
Okay, now we have seen the two main technologies that we based our cloud on, and now we want to show you how we get this into our cloud. First, this is how basically our cloud currently looks like. We use that. We use a hybrid cloud where we have one region, that's the Nomad and console feature that Thomas just talked about. We use one region where we have a self-hosted vSphere cluster, and then we have an AWS on the other side. And there are three nodes that we always need in each region, and that's the console and Nomad node, and 3 is the number, the minimum number that we need to have a stable cluster. And so that one is primary and the other ones are secondary. And we could have separated the console and Nomad, but for our use case, currently we have them running on the same hosts. And there's a leader, and they talk to each other between the data centers too. But the main traffic is within one region. And then we have all the other hosts, like proxies and a database, and of course a lot of those instances where we run our PBXs on. And if one day there's the hockey stick that takes us to new levels of customer growth, and we need more regions, then we could just add like a Google Cloud or Azure or whatever we feel comfortable with, and could add it as another region, and everything would work as it does now with our 2 regions. And yeah, to get this on our machines, we maintain all the orchestration code in a Git repository, and then of course we use, as many people do, Jenkins, and Jenkins triggers a pretty lengthy Ansible pipeline, which does everything. You can start with setting up new hosts, creating DNS entries. You can change host parameters, config files, and upgrade images. And then also from Ansible, we deploy the Nomad jobs that we need to run our actual containers. And Nomad does the rest after we have deployed the jobs. When we do this, we actually want our machines to have a pretty stable state, and we don't want live changes in our systems. We actually wanted to title this this slide as immutable infrastructure, but actually it isn't, because we don't replace the hosts and set up new ones, but we upgrade them. But when we do, we don't do some things like apt update, apt upgrade and stuff, but instead we install a new image and then just reboot the machine and boot into the other system. We have a setup with an A and B system, like maybe from some, like Juniper routers. They do the same kind of stuff. And then we have a live CD Linux system with persistent storage where the configuration is stored. And on an upgrade, we just use new images, and we do that with a host system and with all the containers as well. And that approach gives us another nice feature that a lot of our developers and testers use. We can set up a cluster in a box with just one Jenkins click. As a developer, you can develop write some new code, implement a new feature, and then build a release of our current stable build and with your changes. And then you just tell Jenkins to deploy this build on a new AWS or vSphere machine, and it will do everything from setting up the host to giving it an external domain name, and then write you an email at the end and say, hey, there's your machine, you can use it now. And it will even generate a license, so you're ready to use a pascom PBX. And that's something that our developers use frequently. There are a lot of builds every day where someone tests their changes, and yeah, that makes live and working pretty easy.
Yeah. Basically, the last step brings the developer back to the state where we started. He gets a single box where everything is included.
Yeah, but it's just a box, a box with a whole cloud in it.
Yeah, yeah. The content is totally different, but from the outside it looks same.
Yeah.
Okay, so what's the final result of our adventure of building a new cloud system? So if you remember this picture about the Kubernetes, that's not what we did. We did something else. We tried to build something like that. It's not the same. It's not as big as this Netflix and Kubernetes image, but of course it's much better than what we had before. If you remember this slide with our first cloud, first cloud and this few boxes that we had. So that's what we try to put online right now, and I hope it will last for the next few years. So, do you have any questions about this stuff?
Thank you very, very much, Sebastian and Thomas from pascom. And I'm going to just jump on stage and see if we can see any questions for you. So, having watched that presentation about innovating your infrastructure, any questions for Thomas or Sebastian, or even both from pascom? I'm not seeing any hands get raised. Let me just jump into the room and check for chat.
Nothing in the chat.
Oh, Moshe has got a question. Is your mic on, Moshe? No, is the answer.
There you go. Thanks, Nick.
Okay, listen out, guys. Moshe has a question.
How difficult was it to migrate from LXC to Podman? In other words, I have a very, very, very modest project in hand, but LXC is driving me slightly crazy. So tell me about how difficult it is to migrate from one to the other.
So actually, from development purposes, it was relatively simple because we had a fully automated build chain before, and it was working by starting, let's say, vanilla container based on Ubuntu, basic Ubuntu image, and then we just installed into it what we wanted, and we changed all files to look like we wanted it. And this snippet of the code just kept the same when we moved over to Podman. Of course, our build runtime has to be changed. It needed to start an empty Podman container instead of an empty LXC container. And we need a few package more or less because the base images were differently. But at the end, really converting this content of the containers was not so hard. It was relatively simple, especially because we can still run our systemd-based solution. And yeah, so I can recommend it.
Thank you very much.
Thank you.
There are some pitfalls when having privileged containers and using the right IP address and stuff, but that's that's something that's all manageable.
Yeah, it will be interesting to see what Sandro does to our new system.
Great, thank you. And thank you again, Moshe, for that question. I don't see any more questions in the room. There is a question in the room. There's a gentleman coming along. Just bear with us. And here comes your question, Thomas and Sebastian.
So what drove your decision to use Live CD or similar base OS as opposed to one of the other projects out there, like Yocto or Bottle Rocket or whatever became of Red Hat Atom?
It's because of our history. Because we had this CD approach already back at the days when we installed to bare metal. So actually, it already existed when I started in the company some 12 years ago. And we refined it over the years. So back then, we didn't have this A-B kind of deployment, but the basic infrastructure was already here, and we refined it over more than 10 years. And that means it works for us since a long time. Of course, we could move over to, let's say, Project Atomic or something like that, or CoreOS. And it's really quite similar to our homegrown solution. But for now, it's not necessary because we don't have a problem there.
Great, thank you. Did that answer your question, sir? Wherever you were. Yeah, Yes. Okay. Good news. Well, look, let's give a very big ClueCon thank you to Thomas and Sebastian over there at
there's
Germany.
there's a last question, I think, in the.
Sorry, I missed that. Go ahead.
There's one more question in the chat.
Oh, sorry. Go ahead.
Yeah, that just came in. How do you handle failover for Nomad and Podman?
That's an interesting question, actually, and it is not so different to have a failover there. It's quite similar to how you would handle it with Kubernetes. So if it's, let's say, a stateless service, an HTTP router or something like that, Nomad will just start a replacement service on another node, right? It can do the same also for an entire PBX. Of course, the customer will be disconnected for, let's say, something like a minute or 1.5 minutes. But it's the same like in Kubernetes. It creates a replacement container and just routes traffic to it.
Great, thank you for answering that question from the chat. Now, I just want to mention that pascom are in fact one of the sponsors of ClueCon this year, 2021, along with Flying Voice, XSwitch Cloud, Prompt.io, OpenSips, and of course, FreeSwitch and SignalWire, not to mention Oryx as well, who are locally based, I believe. So let's just give all those sponsors a round of applause for helping make ClueCon possible.